Okay, this is the question from the communication system. This question is given in the previous GATE paper in the year of 2000. GATE 2000. This question is given from the communication subject. The topic is related to the digital carrier modulation techniques. Okay, now we'll look into the question. In a digital communication system employing frequency shift keying FSK, the 0 and 1 bit are represented by sine waves of 10 kHz and 25 kHz respectively. These waveforms will be orthogonal for a bit interval of. Okay, the given options are 45 microsecond, 200 microsecond, 50 microsecond and 250 microsecond. Okay, here the digital communication is given as, that is nothing but the FSK, the frequency shift keying modulation. Okay, in this FSK system, the 0 is represented by a sine wave. The corresponding frequency of that sine waveform is 10 kilohertz. Okay, similarly the 1 bit is represented by a carrier, that is sine wave. The frequency of that sine wave is nothing but 25 kilohertz. Then if it is converted into the frequency into time duration, the time duration for the 0 bit is considered as the TB0. Then that is nothing but 1 by 10k, that equal to 100 microseconds. Okay, similarly the bit duration for the 1 is equal to 1 by 25 kilohertz. Okay, that is nothing but the 40 microseconds. Okay, these are the durations corresponding to the two sine waveforms with respect to frequency 10 kHz and 25 kHz respectively. Okay, here we have to find out the where these two waveforms are orthogonal with respect to interval. Okay, for orthogonality in the FSK, for orthogonality in TB duration, okay, the orthogonality for the bit duration TB, there should be integer multiples of the bit duration. So we require integer multiples. So integer multiples of the cycles, the duration cycles are equal to the orthogonal each other. For example, the first duration TB0 is considered. The TB0 is the 100 microsecond. Okay, the integer multiples are 200 microsecond, 300 microsecond and etc. Okay, similarly for the bit duration TB1, the main first duration is 40 microseconds. The integer multiples are 40 microseconds and already it is there, that is 80 microseconds, 120 microseconds, 160 microseconds and 200 microseconds, etc. Okay, if we observe the integer multiples of the both the bit durations for 100 micro, 200 microseconds, 300 microseconds and etc. Similarly here 80, 120, 160, 200 microsecond. Okay, this 200 microsecond, this 200 microsecond is common to the bit for the 0 and 1. Okay, at this 200 microsecond both the bits are orthogonal to each other. Now the solution for this one and answer is 200 microsecond. Okay, at the interval of 200 microsecond these waveforms are orthogonal.